Well, hello, welcome to the little shop, and here we are, part 2 of the British invasion. This is an original 18 watt 210 amplifier. It just picked up recently, and it's had a bit of a rough life as well. It's been roughed up some here and there. We're going to try to get this full back to original state as well. Right now the wattage seems to be a little bit low. A few other things going on. It's had some really messy work done in it. We're going to try to get it straightened up. So let me spin it around here, let you check out the back side of it. There's your first look at the rear of this amplifier. First off, you can see that the two speakers don't match. We don't know if that's original or not. You never know. But you can see in here there's been some pretty shoddy work going on. I noticed the pilot light was a little dim on it. I couldn't figure out why until I looked in here. And of course it's the original radio spares. So we get that light glare off there. It's the original radio spares pilot light. It's a 200 to 250 volt pilot light, so running at 110, it's a little dim. You can see where things have been a little messed up here. Someone's added a couple resistors for a center tap for the heater, and one of them is not even connected, and the ground's loose. Like I say, there's been lots of bit shoddy work going on here. Here's your look at the top panel. I've leaned it back so the glare is not so bad. We have 2 channels, volume, tone, tremolo. Like I say, we've got 2 slightly mismatched speakers. They're the right speakers, but who knows whether they're original or not. Everything's a little cruddy and nasty in here. The amp works, like I say, but it's a little bit, seems like it has a little bit low volume. I seem to have about 60 volts low on the power supply. We're going to see if we can figure that out. The owner mentioned having the cable replaced too, since it's only like 4 feet long, and this cracks me up. Now you're going to hear me make comments about these amps because things just aren't the way they should be, but anyway, I've made the comment a few times about at this time of amp industry, it was in its infancy. And we're dealing with a situation here where standard practice was tying a knot in the AC cable to keep from pulling out of the chassis. That's what we're dealing with. So, and that is not an aftermarket thing. That is probably what was done originally, even though it is a new cable. We're going to tie it down. We do have the original foot switch for the tremolo. That's a plus, even though the bottom plate's going forward. But anyway, let's get some of these bench lights turned off and get rid of some of this glare and get at it. Well, we have it out of the cabinet. You can see the original power transformer here, the original output transformer. We've got the original power supply caps. We've got a GE 6CA4 rectifier tube. The output tubes were a pair of Solvtex. They've been running rather hot from the previous measurements I made. Nothing spectacular going on here. It looks like we have a GE tube in position 3, and if we're really lucky, I can't tell for sure without doing some more closer looks at these preamp tubes, but they may actually be Mallards. If they are, all the markings are worn off of them. This is where I left off last evening, so I'm back and all refreshed, ready to go at it. So I have everything ready here. I have my cleaning supplies, I have my water, I have solder, I have my solder suckers. I put a new soldering iron tip in my soldering iron and cleaned up a big boy here. I have my 18-watt file up and running, ready to go. Oh, while we're here talking about this, hang on, I need a pointer. Okay, I have the original Marshall schematic up here, and I want to point something out. There's a mistake in the schematic here. If you wire, we'll discuss this later a little bit. This connection is wrong. This connection is wrong. If you wire it up as shown, you'll be wiring your output tubes up as triodes. So, going back over here and getting at it. We're ready to really start putting this thing back together here. It's going to be a bit of a challenge. There'll be a lot of work to do, a lot of lead dressing and layouts to do and change. We actually have a problem here. I found the heaters was wired up as a common heater. They're supposed to have two separate heater windings on this transformer. Of course, a lot of the numbers are rubbed off, worn off, painted over, varnished over, whatever. I'm going to have to go in here and figure out what's going on here with these. I know what the primary wires are. I know what the main B plus secondary wires are. And here is one heater lead, but there's supposed to be a 2 amp heater section and a 3 amp heater section. Okay, I thought I'd get back to you here and get you caught up a little bit. There's been quite a few hours put in here. You can see where I've actually tied down the AC cable, grounded it to the chassis here with a solder joint, not a screw. Had to configure the wiring for this transformer. Funny thing, there's not a whole lot of information for this particular transformer out there. So, you know, guess who's got info on it. Anyway, as it turned out, I found out how to wire it. And I got my voltage up. It was wired wrong when it came in the shop to start with. So I've got my voltage up, I've got my wattage up. I've rewired a bunch of stuff down through here. I've redone pretty much the entire heater circuit. I got rid of a noise that I had in the phase inverter here. Had rerouted a whole bunch of leads, a lot of new leads. Still have some cleanup work here to do, but we're trying to get it running at this point. I actually have the power amp running. Our bias looks good. We've got all that taken care of. Probably changed some caps here yet, maybe a few things, but we're just trying to get the amp up and going right. So I've actually nuked everything up here because it was in such bad shape and done so poorly that we're going to rewire all of it. It had been modified in a few things there too, so we're putting it back to stock. So there you go. That's where we are now. We're basically done to this part of the circuit. Like I said, there's going to be some tweaking and some readjustments made and some new parts thrown in here and there. Possibly. Not a whole lot. But we've got the power amp and power supply corrected. Moving on to the preamp. Well. We have this running. We have the tremolo working. We have both channels working. back engineering something that someone has butchered up is pretty difficult. I actually found a photo online of this board. I say, keep in mind, I found 3 different boards in these amplifiers. So I found this board in one online, which gave me an idea of what I needed to be doing in this area for the tremolo. And something else I did was I moved the tremolo from over here to here. I put the phase inverter down here closer to the output tubes, just made more sense. We still got a lot to do. We've got another factory knot here for the tremolo cable that we're going to redo it later. It's one of the last things we're going to do. Had to put a little terminal strip down here to mount 2 parts to. But anyway, we've got this little guy up and running. Everything's working right now. Had to completely rewire the tone controls, especially on this channel, on the vibrato channel, because I don't know what this guy was trying to do. But anyway, he changed everything over here and it was a mess. But anyway, we've got it running. So I'm going to clean up some more stuff. We're going to change a couple caps over here. We're going to clean up some more wiring. But my big thing is, right now, I have everything working on it. It's been a battle getting here. So, we shall carry on. Well, let's catch you up a little. I have the board all completely finished and everything there. As I said before, everything's working. Getting to this point was a big one. We wanted to get everything working and see how everything could shake out. Our wattage was still a little bit low. Our power supply was still low. So there's been some changes made. A lot's happened since I left off before. This little guy, come out. That's not original. As much as we wanted to believe it was, the owner really was hoping that it was. The previous owner had no idea. But the voltage was way too low and the current was too low. But we got the amplifier working before we had to change it. We have the new transformer in. Used the original mounting tray here and all that was there. Yes. So I put a Mercury clone of the 18 watt in it. That's why it has the terminals and everything on it. I did that. Everything started working a whole lot better. My voltages come up. I got a few more things to take care of. I have a little bit of ripple on the power supply. On the first stage, I'm actually thinking might be a bad section in the new filter cap. We're going to check that out next. Our bias is running a little hot. Before it was too cold. I may tweak the screen resistor for that a little bit. I would like to see about 35, 38 mils on these. They're running about 350 volts. Right now I'm running about 47. And that is plate current only, not the screen current added on. So I got a little tweaking to do yet. We were sad to see this little guy go, but you know, current was way too low. It was only like 90 mils on this transformer. And this actually gave me the other heater leads like I was supposed to have the independent rectifier heaters and separate audio tube heaters that are center tapped. The rectifier tube is not center tapped. So here we go. You're caught up. Thanks, Dave. Anyway, okay, we'll get back to you when the tweaking begins. So we're back at it here, and I've been working on this power supply ripple thing. So I'm going to share one of life's mysteries with you. This just cracks me up. Anyway, let's go over here. This is the wave coming off the speaker with no signal in the amplifier. Now, we also have that same sawtooth wave. Hang on a minute, let me change hands here. This is going to take a second. We have the same sawtooth wave on our first filter stage of the power supply. This is why I thought we had a bad filter. To make matters even more complicated, if you applied signal, we had signal modulated on top of it. Okay? So, how do you fix such a thing? Well, it took me a little while to figure it out. I thought for sure it was a power supply problem. But imagine this. It's going to take a minute for the scope to kick in here. Look at that. We go from this to this. And that's actually on the speaker output. You want to know why? I grounded the one side of the output transformer. So not the positive side, it's the negative side. This amplifier, the transformer leads come right off the transformer. Oh, wait a minute. Let's just explain this to you. Okay, you see here, here's your primary for the output transformer. Here's your secondary. These leads come straight off and go to the speakers. They're not connected to ground. So if I connect the black one to the chassis, this problem goes away. Hang on, I'll show you something else. Okay, so we're back here. Let me show you this again. Here is our signal with that problem. Alright? I'm juggling a lot of things here. Ta-da! Look at that. And we have this beautiful little signal here. Okay, mystery solved. Who would have thunk it, right? Okay, now that we've solved that mystery, let's move on. I have 125 ohm resistor tacked in here to replace the 100 watt original one. That actually brought my plate current down a little bit, but I'm wanting to check this green current here and see how it's living here in this amplifier. So we're going to disconnect this resistor, which is our screen supply resistor, and we're going to insert my amp meter between it. We're going to see what these screens are drawing. Alright, well, we've done some checking. I hate it when I'm right. Anyway, I got looking here. Maximum screen dissipation on an EL84 is 2 watts. So if you do the math, at roughly 330 volts on the screen, it turns out that maximum current should be about 6 milliamps per screen, which is fine at idle. So when you run this little guy up, we get up here. We're like 3 times above maximum plate dissipation. That's not good. So we're going to have to cool these screens down a little bit. Well, we've been doing some tinkering. We've been doing some measuring, some calculating, and some running. So I've changed this screen supply resistor And I've got us down now to about 2.5 mils at idle on the screen on each tube. So we've got 5 mils total at idle. This is no signal. So let's bring the signal up. There I'm at my 12, which is maximum dissipation on the tubes. And that is, hang on, that's about halfway up on the volume. There's full out. So we're less than half. Well, so we're full up. We're not quite double screen dissipation max. Now, it's okay to go max or over max on occasion on one element of the tube or so, but you can't do it on all at once, or, you know, smoke ensues. But anyway, so I ran into something else here. I noticed that there was a bit of ticking going on here at the tremolo. Now, I've corrected the problem. I have a pointer here. Earlier, I had a serious motorboating problem. And I noticed earlier that if I had moved this wire around, I could speed it up, slow it down, almost make it quit. I could get right down to a putt-putt, or I could have a steady beat with the tremolo. So from the Sneaky Tricks file, I've got a piece of shielding tape down here over this wire. This is actually a plate lead for the tremolo tube. And I found out if I strategically placed it right here in this point, that the noises would go away. So what I'm going to do is tack solder here and here and here and here so this doesn't come loose over the ears. But I've got this quieted down to where you just barely hear a little thump right now. And that is with the volume for the tremolo channel turned all the way up. If I turn it down, there's nothing. Okay? I say, just another one from the Sneaky Tricks file. So let's take a moment to show you what I did here this morning. I took a few minutes to fabric hobble a steel bracket here. It's flush with the end of the chassis. You can see I mounted it underneath the foot of the output transformer. That is to hold our speaker jack, which is going to serve two really important purposes. One, it's going to provide us a ground of the chassis like we need. And two, it's going to take the stress off these little transformer terminals up here. I noticed the leads were very short. These are very fragile, like I say, you can always see where the corners are been broken out here at some point. But it wouldn't take much to rip one of these leads out of here. So this will be a safety factor for that. We can use a 1/4 inch plug here to put these speaker leads on, so you can unplug these to take it out, service it or whatever. The leads were very short. I was afraid if you'd happen to snag one of them or get caught on something, it might actually do damage to one of these terminals or to the speaker terminals, which are equally as fragile. And he can actually run another cabinet with it if he wants to. He had asked me if we could put a jack on it without drilling any holes anywhere in the chassis. So this is a good alternative. That way he's already talking about running a 410 cabinet on it, so we'll see what happens. And a little bracket came out fairly well. As one of my friends JT would say, well, it doesn't look too hillbilly. So anyway, there you go. This is how we're going to solve that problem. Speakers are wired up. The original speaker leads were a little short, so I used the longer portion that went from here to the amplifier here and added these new ones here. And we've got a plug. That part's done. That was easy. So, even though I have this running to where I think it's safe, the little voices in my head made me work on it all night in my sleep last night, and I think I can do better than this. So we're not going to let it go at this. So we're going to try to get this thing within limitations of these tubes just to make it safe. So we're going to get into it some more. Alright, we've tacked in a 4.7K resistor right here instead of the 1.5, the stock. Some of their versions ran as much as a 2.2 here that I've seen. Okay, now over here I've got a 470 ohm resistor. I replaced the 100 ohm there. This is your screen current limiting resistor. 100 ohms doesn't really limit much of anything, so 470 is pretty safe here to help the tubes out a little bit. We've got about 325 volts now on the screens. So let's see what's happening. Oh, we got glare. That's what's happening. Okay, we got 5 mils on both screens total. So that's 2.5 mils per screen. And we're bringing the signal up. Okay, there we have 7 mils per tube screen wise. That is 1 mil over what I'm supposed to have per screen. I'm calling it done. Now, that's much better than the 22 or whatever we had. So, the next move is to see what our plate current is. See if it's changed any. Okay, our plate current has come down a couple mils. That's good. We're now at 35 mils. Was 37. Target range is 34. This is great. I'm going to solder some parts in. And as it may just happen, my buddy the owner is showing up here in a little bit. We're going to get this thing stuck together so he can try it out. Well, we're winding this job down. We've got a few little details here to take care of, and since I'm waiting for some parts to show up that, well, suppliers just can't seem to get right. But anyway, that's a whole nother thing. So what I'm going to do is I actually need to fabricate a bottom plate for this. We've cut off his other knot. There's, you can see where the wire's already rubbed through here from being bent and broken for years. So we're going to make a new bottom plate for this. I have found that original Crybaby feet will fit this. So we're going to use those. Getting to this, the original logo has had most of the lugs broken off the back of it. And he would like to keep the original logo, so we're going to make little pins to use on it. The plan is to take this plastic pin that's actually supplied with a K&K guitar pickup. We're going to turn the diameter of it down to match the size of the original pins. We're going to drill with the drill press where the original pins were to give it a little footing for them. We're not going to drill all the way through, just going to put a little seat there for it. I'm thinking about only using 3. I believe this had, let's see, 1, 2, 3, 4. This originally had 5 pins, but I think we're going to go with 3. So I'm going to get started turning this down. Basically what I'm going to do is probably refer to it as a poor man's lathe. I'm going to chuck this in a drill and use a sanding stick and turn it down. So I'll be back. since the original pins are 132 thousandths diameter roughly, that's what we're going to shoot for. Fingers are all sanded off from doing frets. And this is 179, so we don't have to go too far. Close enough. I quit. See? You can see we turned it down. Alright, there we go. 3 new pins, all in a row. As I only added 3 here, I left the one out at the A because I thought it was just too close to the edge, and it may drill into the outside of the A, so that's why I only went with 3. So like I say, the one over here on the L's is the original one. Everything else I've done. So these are epoxied in. We will let it set over the weekend. Actually, it's only 8-hour epoxy, but I'm gonna be gone, so I'm gonna let this set, and we'll get back to it later. Whether he wanted me to do it or not, I thought this needed a cover on the bottom and some feet. And it may not be perfect, but I actually found that crybaby feet fit it, sort of, a little bit bigger. Trying to find something that fit this is almost impossible. Luckily, the screws matched the threads. So I cut out a nice little piece of aluminum for the bottom of it. But trying to match something like this is pretty tough. You have corners that are round, corners that are not round, corners are absolutely square. Anyway, so that's that. All we got to do is stick his wire back in here and put a factory style knot in it, solder it up, and this part of it's done. And we have another surprise over here.
I managed to get the logo back on. With the pins that I made for it and all that, we're in good shape. And whether it looks like it or not, it is level and centered.
The script kind of throws things. Well, we're getting this finished up here. I had a little tweaking I wanted to do. Like I said, it's winding down. A few little last details that had to be taken care of. So we added our new resistor here. Actually added a couple more leads here. The more I looked at it, I couldn't leave this stuff in here. We're looking at stuff like this that was burnt, melted, you know. A lot of the leads in this amp's been changed just because of stuff like this. Like I said, a lot of soldering iron damage over the years. And if you remember, this amp was quite a mess. So we've got all that taken care of. We've added a couple little things down here. I've got a grommet I've split apart and glued to the bottom of the tube holder. And look here what I've done. I actually made sure that the springs for the mounts didn't touch the tubes anywhere, so we didn't have any rattles or noises. We had a problem with that. But we're all pretty much done here. I have one more little thing I want to do, and it's one of my little pet peeves about tremolo circuits. We've got everything quieted down, everything is great, but let me plug in a signal generator here. Hang on. Basically, I've just plugged a cord into the tremolo input, so what you hear is hum and a tremolo. But that is the slow speed. There's something I've been doing for a long time on Fenders. stay the same. It still goes fast as it did earlier. But the slow is a lot lower. If I hear it again, okay. So what I'm going to do is tack another capacitor across here to take care of that problem. Okay. So on another interesting little side note, I had a new customer in the shop a couple weeks ago that has moved here from north of us, and he was picking up his first repair job, and we got talking about amplifiers, and he was talking about buying a new 18 watt Marshall, and he was talking about headroom and this and that, and I said, well, I have one here, one of the old ones. I said, it's not going to be the same as a new one, but you might want to try it to see if it's even close to what you're looking for. So he didn't try it and went ahead and bought one and brought it in to compare them. And he played through his new one a little bit and plugged into the old one here and made the comment immediately after playing just a few notes and chords on it that there was no comparison, that this old one sounded immensely better. The harmonics, the richness, everything was there. And he says, is it the old speakers? Is it the old parts? I said, well, it's just a different amp. So he made the comment of, well, what can we do to make the new one sound like this? And I said, I don't know. So anyway, but that's for another story later. But I just found it amusing that after this amplifier had been resurrected from the butchery that I'd seen, that frankly just smoked the new combo. So just thought I'd toss that in there. I'm going to get this thing together, and we'll see if we can get you a little bit of an idea of what it sounds like. Okay, let's see if we can give you an idea here a little bit what this sounds like. I have the volume on the vibrato channel here barely on 2. Tone control's halfway up. It's halfway up now. There's our tremolo. That's with the speed all the way down. There's intensity all the way up. So you get the gist of that. It's actually a little bit more responsive. That's half volume on it, roughly. Shows you the range of the tone control. So that's enough of that. Anyway. No more, no more. So anyway. It's what happens when you're a full-time repairman, no-time guitar player anymore. So anyway. That poor guitar's only been out of the case. Check out amplifiers lately. So anyway. There you go. 18-watt Marshall. Restored in all its glory. Class A, basic amp. Part 3 will be in a bit, so be patient. But it will be coming. And it's going to be a good one. So, till next time.